Hello, welcome to our program, Astronomy for Everyone. In previous shows, we showed you how you can observe with using your eyes and also with using binoculars. In this program, we're going to go to the essential part of our hobby. As far as equipment is concerned, we're going to talk about the telescopes. In this show, we'll talk about telescopes for both beginner and intermediate observers. With me here in the studio is John Schroer, a fellow Ford Club member. John, welcome to the program again.
It's nice to be here, Don. Thank you.
You're welcome. Now, we're going to talk about three different designs of telescopes in our show. We're going to talk about the refractor, the reflector, and the compound telescope. But with each one of those, there are three things that you need to consider that we know as the 3 Ps. Can you tell our viewers about that?
Sure. The 3 Ps are price, performance, and portability. Any one feature is going to affect the other two. Price is how much you can afford or you're willing to spend to buy a telescope. Portability, how easy is it for you to set up the telescope, take it outside, and go and observing? If it's a real difficult telescope to set up, you're not going to be as willing to go out as often to use it. And then there is performance. You've got to be able to see some things through the telescope, and that's going to be adjusted by the price.
All right, well, why don't we start out with this first telescope right here. This is a refractor. What can you tell our viewers about it, John?
Well, when you ask anybody in the general public, what does a telescope look like, they'll point to something like this. The refractor uses lenses to bend light. As you can see in this video, light from the stars goes through a pair of lenses where it's bent to fit into a small cone, which bounces off the second mirror, the secondary, and then up into the eyepiece, where you can actually focus it and see a nice image of Mars, which is up in the sky, or the moon, or anything else you're looking at.
Great, and I see we have a couple of other items attached to this particular telescope. What's the story behind those?
All right, the first thing you're going to notice on this little telescope is this is the finder scope. This gives you a wider field of view of the sky than the actual large lens. So this has a pair of crosshairs in it, so you would aim it at the moon or Mars, and then, if this is properly aligned with this telescope, when you look into the accessory called the eyepiece, which allows you to focus the light, you should see a nice clear shot of the moon or Mars.
Great, so the type of mount that this is on, what type or design is this?
Well, this is using a standard photographic tripod. You can loosen the handle, you can spin it in any direction, north, south, east, or west, in azimuth, and you can also adjust its altitude, how high you want to look to find a particular object. Now, this mount has a little add-on called slow motion control, and with these two knobs, you can make very small adjustments in the height, or very small adjustments right or left. So you can follow something as the Earth rotates, things appear to move in the sky. This allows you to keep them up so you can keep looking at that particular object.
Very interesting. I see we have another scope right next to us.
Well, certainly.
This one is the reflecting telescope. And what can you tell our viewers about this one, John?
Well, this is a Dobsonian telescope. It is basically a telescope that uses mirrors to gather starlight. There's a very large 10-inch bowl-shaped mirror at the bottom of the tube. That captures the starlight, and then it's bounced up into, again, a cone, like in the refractor, but it goes to a second mirror, called the secondary, and then it goes up here into the focuser, where you can actually look at it using the eyepiece.
Very interesting. Now, this was the type of telescope that was developed or invented by Sir Isaac Newton, correct?
That's correct. He saw that there would be a limit because the quality of glasses they used for lenses. So he figured with a mirror, you could you can gather more light. You would not alter the starlight. You would get a better view. And with this kind of telescope, you're talking about one that can grab much more light than, say, a small refractor. That refractor has a lens about 3.5 inches wide. This telescope has a mirror that's 10 inches. So you gather much more light. You can see much fainter things up in the night sky.
I noticed, too, that this telescope has very similar accessories to our first telescope.
That's correct. It has a finder, so you find the object you're looking for, and then you can use the eyepiece to look through the main telescope and focus it and really get a nice view of the sky, or any object you're looking at, a galaxy, a star cluster, and the moon and Mars as well.
Now we can see that the base or the mount that holds this telescope is much different than our first example. Can you tell our viewers about this type of base?
Yeah, a gentleman by the name of John Dobson came up with the idea of moving a telescope by aiming it like a cannon. You can rotate it right to left, and then you can also tilt it up and down. So it also has attitude and azimuth adjustment. But because it has no fancy gearing or computers or anything else, that makes this telescope very affordable, but you get a lot of performance because you have a huge mirror to gather the light from the universe to observe with.
You mentioned price. I'm sure our viewers are very interested as to what these types of costs run in general. Can you give them an idea of their costs?
Well, the telescope, the refractor, the little one, you can get that for about $150. The tripod, the slow motion controls are extra. That would take it up to close to $200 or so. This 10-inch Dobsonian has a unique feature. It has a computer and digital encoders. So you can basically program in an object, and this computer will tell you where to point the telescope and how high and how low to aim it, and you'll say, okay, you look in your eyepiece, you should be looking at the moon or Mars. So this is not a go-to telescope where a computer does all the work. It tells you where to push the telescope to see it, so people call it a push-to.
All right. Well, there are some other accessories that you can use with both of these types of telescopes, correct?
Absolutely. Some of them are on the table here in front, and they include, if we can walk around here, you can see the large black object. This is an additional eyepiece. Eyepieces, depending on their size, will let you either get a wide view of the sky, and that's with a higher millimeter number, or if you get a lower millimeter number, say a 9 or a 6 millimeter, that means you're getting much more magnification, but you see a smaller part of the sky. If I can rotate this around, you can say this is a Celestron, and it's a 32 millimeter, so that's made for a wide view of the sky. Now, next to that, we have a filter. Now, astronomers use filter. For example, they use a color filter to look at Mars to bring out some of the dark features on its surface. Or you would use a neutral density filter if you're looking at the moon when it's particularly large, because you look through a large telescope at the moon, the light would be so intense you would ruin your ability to see clearly at night. So you have a filter that dims down the light of the moon so you can enjoy the view and still be able to look and see what's going on in the rest of the sky. Also, you're going to need some things to help find your way around the sky. And there are books such as, this is the Observer Sky Atlas. This is a very small paperback edition, which helps you find some really interesting things you can see with a telescope or even a large pair of binoculars. There are also things such as astro cards. This is an astro card, if we can get a close-up of that. There we go. It shows you all the deep sky objects in the constellation of Leo the Lion. Now, this is a card reader which has a small red LED light, so you can read it at night and not damage your night vision.
Very interesting. And of course, you can also use planispheres or other types of star maps as well to find the object that you're looking for in the night sky.
Or you can even use a computer program. There are many free ones and ones you can pay for that also help you plan your observing session, the things you want to look at for tonight.
Well, great. Well, if anyone has any questions, you can send us an email to our email address that you can see at the bottom of your screen. And right after this short public service announcement, we'll be right back to talk more about telescopes.
Making the world a better place is an intricate puzzle. And piece by piece, the women and men of Rotary have worked hard to fight hunger, promote literacy, and move the world toward peace. But there is still much to be done, still some missing pieces. And one of those missing pieces is you. Learn how you can help Rotary put together a better world at Rotary.org. Rotary, humanity in motion.
Welcome back to our program. In part one, we talked about a refracting and a reflecting telescope. In this segment, we're going to talk about the reflector again, using a slightly different mount. We're also going to talk about the compound type of telescopes that you can find on online resources and in retailers. Now, John, we were talking about the reflector, and right here, this is also a reflecting telescope, correct?
That's correct. It's based on Isaac Newton's design. The difference is how it's attached to the ground. This telescope has what they call an equatorial mount. And what the equatorial mount allows you to do is, let's say you're looking at the moon or looking at Mars. As the Earth rotates, Mars or the moon appear to move from east to west. So we're using these slow motion controls, or more expensive equatorial mounts motors. It will actually allow you to track an object across the sky. So you can look at Mars for a very long time, you can do sketches of it, and you don't have to worry about the telescope.
So in other words, instead of pushing it with their hands by using these manual controls, they can keep the object that they're looking at in the field of view.
Yeah, it makes it much easier for you to observe an object over a long period of time. For example, if you want to look at Jupiter and the 4 moons that are flying around it, if you watch Jupiter over a couple of hours, you can actually see the moons, Io, Europa, Ganymede, and Callisto, orbiting around it. And that requires a scope that lets you track Jupiter as the Earth moves once every day.
Now here on this telescope, we also see the same type of accessories that we talked about on the other scopes.
That's correct. We have the finder scope to let you get close in to the object you're hunting down, and then using the eyepiece with the focuser allows you to use the main mirror in this telescope to actually observe the object up close.
Now this small finder scope that we have attached right up here is like a small telescope in and of itself, correct?
That's correct, but it gives you a much wider view of the sky than the main telescope. So it lets you get the telescope kind of close to where you're looking, and then you use the eyepiece in the actual telescope to lock in, so it's in the center of your field of view.
Now there is another type of viewfinder on the market for some of the telescopes called a red dot finder.
That's correct. Red dots, or some of them are called telrads, and this is a low zero magnification view of the sky with a set of circles or a single dot. So you move the telescope around until the dot is hitting the object you're looking for, such as Mars or Jupiter or the moon, or a galaxy for that matter, and then you can look through the eyepiece and then observe it through your main telescope.
Very interesting, John. The last scope that's right behind you over here is of the type or design known as a compound telescope. Can you enlighten our viewers on this particular style?
Yeah, most people think of telescopes that astronomers use with lenses, those that are refractors. That's the kind of telescope they have in mind. Nowadays, almost all modern telescopes used by professional astronomers and amateurs use mirrors. This telescope that you're looking at here is this is a Schmidt-Cassegrain. It actually uses both mirrors and lenses to work. Light comes in through a lens at the front of the telescope. It then enters down and hits a donut-shaped mirror at the bottom. Light is reflected back up to a second mirror, which is actually part of the lens we talked about. And then the light goes down here where it hits another mirror and up into the eyepiece. Now, the mount it's on is a single-arm computerized mount. And what that means is hidden from the camera point of view, which we will rotate around, is a control pad. And this allows you to put in the date and time, put in your location, say, I want to look at Jupiter, and then the telescope, once it's aligned, will know exactly where Jupiter is in the sky, and it will automatically move it, and when you look in the eyepiece, you'll see the object you want to observe.
So this is a great example of the type of telescope known as a go-to telescope.
Right, you program in where you want to go, and it takes you there.
Very interesting. And these come in a wide range of sizes as far as diameter?
Yep, they come in different sizes. This is one of the smaller ones. They come in much larger ones. And of course, the larger ones come with a larger price. Also, you lose portability because the larger ones, it's more weight to lug around.
Okay.
But performance, this optically is a very long telescope. But because of the optics, it's very portable and small and easy to move about. That makes it a very popular scope to use. You get a lot of bang for the buck with this telescope.
And the price range on this particular scope?
They go anywhere from $600 up into several thousands.
And I know, for example, this one right here runs in the range of $300 to $400 for the complete setup that you see here with both the mount and the optical tube.
Because you're doing the work in finding the object and in tracking the object. You're paying more to have the computer take that work off of your hands.
Well, you know, we've covered a lot of different telescopes, and I'm sure a number of our viewers are very excited to head out and buy their own telescope. Is it a good idea just to run out and buy one, John?
Well, first off, I would say no. No way on earth. If you're going to go buy a telescope, you need to become educated. The first thing you need to do is to, first off, find a local astronomy club in the area. A lot of clubs in the area actually have loaner telescopes where you can borrow the scope for 1, 2, or 3 months, and you get to learn how to work it, you get to learn how to observe with it, and you find what you like and don't like by doing that with different kinds of telescopes. Once you become educated on what kind of scope you want to do, and that'll be predicated on what kind of observing you want to do, then you can go out and make a good decision. If you go out right now without any knowledge, it's like shopping for a car without deciding, well, what kind of car do I want? What do I want to do? Am I going to haul a boat? Am I going to take my kids on a vacation? You've got to know what your needs are before you actually go buy a telescope. And there are places to avoid.
Also keeping in mind the 3 Ps, price, portability, and performance that we talked about.
That's correct. And there are places you need to go to get a good deal on a telescope, and places you got to avoid. Stay away from places like department stores or discount houses or big box stores, because they're going to have scopes that'll say, 6,000 power, and they'll be literally useless because they're not made to observe with. They're made to be sold and then stuck in closet to collect dust for decades. You need to go, if you're going to shop for a telescope, either to a local store that has a reputation. And there are many of those in the area. There's Writer's Hobby Shop in Ypsilanti. There's a Camera Mart in Pontiac off of Telegraph Road. And there are also great online stores, such as Orion Telescopes and Red Spot.
Great Red Spot.
Great Red Spot, which is actually located here in the Michigan area. But you got to know what you're looking for before you go buying one. So if you got money, bring a hold in your pocket, fine. Go to a bank, put it in a savings account, wait for a while, study the telescopes, observe through a bunch of different ones. Go to star parties, which many local clubs have, and then you can decide with some knowledge what kind of scope you want to get.
All right, and as a matter of fact, we do have a big star party coming up next month, correct?
That's correct. Next month starts Beginner Nights, which is a series of star parties held at Island Lake State Recreation Area. That's at Kensington Road and I-96. And on the Saturday, the 24th of April, the Ford Club will be out there, and anybody who has a scope or wants to learn about telescopes, they're welcome to come out, and we'll have 15 to 40 different telescopes they can look through.
And we tie this also in with the International Astronomy Day on April 24th.
That's correct. Events are held at the Detroit Science Center with the Ford Club, at the Cranbrook Institute of Science with the Warren Astronomical Society. There'll be an evening event at Metro Beach Park, and that's being run by several different clubs in the area.
Oh, great. Hopefully we've been able to enlighten our viewers about the different types of telescopes, what to think about before you buy a telescope, and how to go about actually buying that telescope. If you'd like to find out more information, please visit our website. You can see the address down at the bottom of your screen. And coming up next, right after a listing of area astronomy clubs that you can contact and observe with, we will have our next segment called What's Up in Tonight's Sky with Steve Whitty. So stay tuned.
Thanks, Don. Let's look at what's up in the night sky for March 2010. But before we get into what's up in the night sky for March, I want to do just a little bit of talk about a little observing I did recently. On the 20th of February, which is a Saturday, the Warren Astronomical Society had an open house at their Stargate Observatory on 29 Mile at Wolcott Mill. And I didn't bring a telescope, so anyone could do what I did. And we had a variety of telescopes. We had a small refractor, we had a 10-inch reflector, we had a 22-inch reflector. This is all club equipment. And I looked at various objects throughout, well, it was less than an hour. The first thing that I looked at was through a 10-inch telescope. I looked at the moon. And we didn't have a moon filter, which makes the moon dimmer in a 10-inch telescope. The biggest problem that you have is that the moon is way too bright. So what we did instead was we used a high magnification eyepiece, and we looked at really just individual craters. High power magnification also gives you less light. It dims the object, which for the moon is just a good thing. In this image that you can see on the screen, just a little above the center, there's a crater, and it has a little dot in the center, and that is the central peak of the impact crater. It's really a mountain, and it's a little white dot because we're at the terminator. We're at the border between day and night, and the top of the peak has been illuminated by the sun. There's a nice little shadow to the left, and so everything is in high contrast. So what I like about looking at the moon in the first quarter is that you have a nice terminator there, and you can see all these details. Then I went on to Mars, and I looked at it through the 22-inch Dobsonian, an absolutely huge telescope. This image was taken in February by John Kirchhoff, who you may remember from our December Astronomical Gadgets show. John is an avid astrophotographer, and he's got some really good equipment, and he's got a lot of skill, whereas the moon picture that I took, that you saw before, I handheld a camera up to the eyepiece and held my breath and just snapped a whole bunch of them, and one of them came out. That's astrophotography on the cheap. Vesta is in Leo this month, and in the image, in the chart that you can see, there's an arrow, and that's where Vesta is at the start of the month, and it moves more or less in a straight line onto Epsilon Leonis, which is that bright star. Vesta is in the middle of that circle labeled Vesta on the top of the screen at the end of the month. So it moves in a straight line through the month, heading that way. And I looked at Vesta in a very small refractor at the open house. Vesta is a dot in any telescope, big or small, so we used a small, cheap refractor. Binocular view of Vesta is just as good as you'll see in anything. Then I looked at a pair of galaxies, M81 and M82. We used a low-power eyepiece, but in the 22-inch telescope. And we could see pretty much what you'd see here, only you see more detail. You can see dust lanes, but you also saw less detail. I didn't see spiral arms. The moon in March. March starts out with a full moon, and it shrinks down to third quarter by the 7th. It then shrinks further to a new moon by the 15th. It grows to first quarter by the 23rd, and then is full again on the 29th. The full moon isn't a blue moon because the moon didn't actually start out with a full moon. It was just almost full from the previous month. Saturn is up all night. It's in Virgo, near Leo. Mars is in Cancer. It's actually closer to Castor and Pollux from Gemini. Let's go with a trivia, a little piece of trivia. The Milky Way, that's the galaxy that we live in, is about 150,000 light years across. If you could see it edge on, as we saw M82, then the light from the far side would be 150,000 years older than the near side. And that's what's up for March 2010. Pick up and go outside and observe.